This video is going to be on the scientific method. There's a lot of information in this video, so I recommend watching it twice. The first time, focus on the vocabulary, write the vocabulary down. You'll probably have to pause it several times in the video. And then after you get all the vocabulary written down the first time, go back to the beginning of the video, watch it again, and focus on how the scientific method kind of flows. So our scientific method starts with observations. So as people, we are constantly making observations about our surroundings. Whether we know it or not, we're always seeing things, smelling things, tasting things. We're using our senses to observe the world around us. So here's the definition for observation. And there are two specific types of observation that I want to talk about. We have qualitative observations and we have quantitative observations. And the definition for both of those are right here. So you could think of it as we use our senses to make observations. And then qualitative observations are observations that describe something. There are not numbers involved in qualitative observations. Whereas quantitative observations are observations that either measure something or count something. So they include numbers. So that's a real easy way of remembering which ones are which. So once you make your observations, the next step is you are going to start thinking about a hypothesis. What do you think will happen if you do something? So the definition of a hypothesis is a testable statement based on observations and evidence. So you've seen these things around you, and if you want to try something, what do you think will happen? It is important. So in my class, it is important that we use an if, then, because structure when writing our hypotheses. And we would structure it like this. So if, and then you would state what you are testing, then what you think will happen, and then because, and in that part you want to say why you think it will happen. Oftentimes when students write their hypothesis, they just say, I think blank will happen. So that's what most students think of as a hypothesis, but we really want to make sure that we are getting our whole point across. So if you forget this top part, then when someone reads your paper, your scientific paper, they might not know what you're testing or what you're doing. And if you leave out this bottom part, the because, you're not explaining your reasoning, and you won't be being a very good scientist, because you have to be explaining yourself and why you think those things will happen. So always make sure you include your if, then, because hypothesis. So I will put that right down here. If, then, and because. And then once you make your hypothesis, which is that testable statement, now we got to do our test or our experiment. So the next thing is going to be, we are going to be testing our hypothesis, or it'll be completing an experiment. An experiment is just a procedure to collect data, and it needs to be repeatable, and it's used to test that hypothesis. Some vocabulary that's really important when we're talking about experiments are going to be constants and variables. So when we have an experiment, we usually want to be testing for very specific things. So when we're testing for those things, we want to keep as many things as we can constant. And then what we're testing for will be our variables. So constants are going to stay the same during our experiment. And variables are going to be what we're measuring and what will change during our experiment. And I'm going to go into a little bit more detail in variables because there are two types of variables. There are independent variables. And these variables are the ones that change independently. So I like to think of them as the ones we get to choose or the ones that we get to adjust on our own. So we have control over these independent variables. And then as we change our independent variables, we are going to be measuring our dependent variables. So our dependent variables are variables that change as we change our independent variables. So I will give some examples right now. When we plot our data on a graph, we are always going to put our independent variables on the bottom and our dependent variables on the y-axis. Let me say that again. Our independent variables go on our x-axis and our dependent variables go on our y-axis. So if we wanted to run a test and we were testing how much time does it take if our phone battery is dead to charge our phone to 50% life, our independent variable would be that time charging our phone, and our dependent variable is the percent of battery life that our phone has. So we might notice that it charges quicker, and then as it fills up, it charges more slowly. So that would be an example of independent or dependent variables. We also, another example might be if we were testing if we are testing how thick fluids are, or the viscosity of a fluid. And we could test the viscosity of a fluid by dropping a marble through that fluid and seeing how long it takes that marble to touch the bottom of our container. So we might see that the marble drops really quickly through water, so it might just take a little bit of time. Whereas with corn oil, it might take a lot longer to drop all the way to the bottom of the container that corn oil is in. And a constant in this situation might be how much fluid you have in the container. And it might be the type of container as well, because you want to test them all in those same conditions. So those are examples of how you might track the data of your variables. And then once you collect this data, then you are going to make your conclusion. Let me draw this over here. We are going to make our conclusion. And our conclusion is going to be based off of observations we make, but also in our conclusion, we can include inferences. So I'm going to write inferences right here, and I'll put the definition right here. So we don't only use observations in our conclusion, but we can also use reasoning and evidence that we collected in our conclusion. So those would be inferences that we use. And that would be the conclusion of our experiment. And if we do that many, many times, so let's say we do this, and science needs to be repeatable. So let's say that someone else wants to do our same experiment to see if they get the same results, and they should, theoretically. And that happens many, many times, and we decide that this experiment or this idea that we're testing in places is always true no matter where you are, and it's always repeatable, and it's been confirmed by many, many experiments, we can then create a scientific theory after it's been confirmed by many, many experiments. So this would be the definition of a theory, an explanation supported by many, many experiments. That doesn't mean that a theory is a fact. You can't necessarily prove a theory. It just means that after testing it many, many times, it's never been disproved. And you could shape theories and change theories depending on different conclusions that you get. But the theory that is molded by those experiments is just an explanation that's supported by all of them. One thing I wanted to add to the end of this video was the ability to be able to recognize and differentiate good science from fake science. So both of them appear to be going through the same process, but when a scientist is actually properly doing scientific work, they make sure that their experiment that they are testing is very replicatable, so that other scientists can do that same exact experiment and get the exact same results. So when you want to try to identify something that's fake science, you look at what experiment they used or the procedure that they went through, and you got to think, is it possible to replicate that? Or if I replicated that, what's the possibility that I get those exact same results? And you can use that to see whether what happened is fake science or, actual real good science.